Please remember that with geometry, there are often multiple ways of getting to the same answer, right? Especially when you prove example it's parallelogram. So maybe you found a way that's similar that might happen. That's not the right enough. But in the text or exam, if you see something that will work, right? Just do it. Don't spend another 5 minutes trying to find a shorter method. All right, unless it's something that's going to take you like 2 pages of working and you can see it maybe 2 more questions, then you should maybe look for, okay, it's only 2 marks, it should be a shorter way of doing it. But guys, if it's like proof that something's a path and you're going and it's working for you, then just go. Okay. What was difficult about this worksheet obviously was no mark allocation, right? It is quite useful for especially these types of questions if you know how much the question will count, because that does guide you in terms of like how much working or maybe how simple of a question it is, right? If it's maybe a 2 mark question, then you could start thinking, oh, it should be something, maybe something that I'm missing, something that that I'm not seeing. Okay, guys, so 1.1.1, we did talk about that on the board the other day, on Monday, yes. But there was another way you could have done it by stating that these lines are all parallel because of opposite sides of the path. I did use that in the next question, so I wrote it over there. And you could have used alternate angles, right? But then someone suggested that there was actually a quicker way of doing it. If you just remember that the parallelogram has opposite angles that are equal, can you sit down? If this whole angle D is 70 degrees, then the whole angle D is also going to be 70 degrees. But they told you that that angle is 20, so if the whole angle is 70, then ABO has to be 50. Okay. You don't have to write 70 minus 20, that's fine. You can just write 50 degrees straight away. And guys, there's no reason for that step. That's just like common sense. You can see that the whole angle is 70, or if you know that the whole angle is 70, then to get part of it, you need to minus the part that you have. Does that make sense? Okay, so you don't have to write a reason for the 70 minus 20 part if you did it like this. But opposite angles of parallelogram does have to be there if you use the fact that the angles are opposite. Now guys, just to show you on my diagram here what I did, everything in black is what was given. Now I suggest, I didn't say this to you on Monday, but it's maybe a good idea that if we're telling you that it's a parallelogram, to just fill in all the properties that you know. Alright? Then whenever, so that's everything in blue. So everything that I called in here in blue are all properties of a palm that I filled in because they told me that it's a palm. Okay. So for example, opposite angles parallel, opposite sides parallel, opposite sides equal, I put that in. That angle is equal to that angle is equal to that angle, and then opposite that angle bisect each other. So that part, BO is equal to BO, and AO is equal to CO. You might not have to use all of it, but it's quite nice if it's all there for you to see. Okay, what is important is when you then want to use any of the blue stuff, you have to first write it down. Okay, so that's maybe a good idea. We are going to practice some more of this today. We're not doing anything new today, just more practice. So that's maybe a good idea. If you're struggling with it, take whatever part they're telling you it is and fill in all the properties. Okay. Next question. Is there any or are there any questions on the first one, right? Next.
Good. One reaction to the whole.
No.
And then so when say 70 degrees on 20, 70 minus 20.
Are you asking me can you use the degree from the wall?
Well, in the calculation, it's awesome.
Try to remember to write it in and write it more notation. Okay, 1.1.2, guys, for that one, you have to find angle BOC. And like we discussed on Monday, it's good if you are looking at it and you kind of decide what you're going to do before you start writing stuff down. Okay, maybe you just want to write all that stuff down, but what you also want to be cautious about people is just don't write like a page of stuff with no kind of structure to it, because it is incredibly difficult to mark these kind of questions. I think you can understand that. And once you marked 100 papers and everything's a mess, and then you come across maybe one AP student paper and there is actually some sense to what's going on, but you can't really figure out, sure, it's difficult to keep track of what's going on. Okay, so just so that you don't lose out on marks because maybe the teacher that's marking, obviously I know you can take it back to them afterwards, but there has to be some kind of structure. Okay, you need to show the marker actually what you are doing. So I want to urge you to not just write down everything that you can see. So like I said here, fill in the stuff in blue, but don't write everything down because you might not need to use all of it. Okay, try and figure out for 1.1.2, I decided that I wanted to use angle, sum, and triangle because I have that 20, and I decided that I can find BCO, I can find that one using alt angles. So then I use angle, sum, and triangle. That's right. That's right. At the top. Yes. Yeah. Yes, that's fine. Yeah, that's right. Yes. Was that your question?
No, I was just gonna say that.
All right, so that's what I thought, guys. I just decided, okay, I can use all the angles here to find that angle. Then I can do angle, sum, and triangle here. So that's all I wrote down. You see, I didn't write down a whole bunch of other stuff so that whoever's marking this can follow my train of thought nicely. They can see, okay, these sides are parallel. But like I said, of course, you can write that at the top. That's perfectly fine. But then I'm finding this angle because of alt angles, and then I'm calculating my 110 degrees. Okay, so maybe just when you're practicing more questions, just try and do that. First figure out what you're actually doing, and then write that down. Yes, Ian? What is the other way?
I was just gonna say, you know, what AOD.
AOD.
By,
Yeah.
and then you read the third
Good of angle. Yes. Okay, no, that's fine. Just for both of angles, you have to have the word equal or the symbol equal after that. Okay, just be aware of that, guys. That reason is a bit strange. You're not actually allowed to just write both of angles. You have to say both of angles equal. Yeah, I think it is in that list of reasons. I can just find the thing. But that's fine. Okay, no problem. 1.1.3, they asked for angle OAB. Now, I don't know if you guys ever think of using exterior angle of a triangle. I think it's something that's often forgotten, but I actually was able to do this in one step. I don't know if there was another way in which you could have done this in one step. So we have that this is 110. Let me quickly fill that in. We calculated that this one was 50. And that one was 110. That's also another thing, guys. I didn't want to fill in my in-between calculations because I didn't want it to be too busy. But as you're calculating stuff, fold them in on your picture. Okay, because then you can obviously use that. So I decided that, what are we looking for now? OAB. We're looking for this angle over here. And what did we calculate? We calculated this one in the first question. We calculated that that one was 50. Now guys, if you remember that the exterior angle of a triangle is when one side is lengthened, obviously now, right? One side is lengthened, and on the outside of the triangle, you have that angle 110. And what do we know about the exterior angle? It's equal to the sum of the opposite interior angle, right? So if I have the exterior angle as one of the opposite interior angles, I can say that this angle, this star, is equal to the exterior angle minus the interior angle that we do have. Okay, or you could have done angle sum, you could have done angle on a straight line, and then angle sum and triangle. If you want to do that, fine, Daniel. That's fine, yes. Okay, so because you had the 70 here and that 50, or did you use it here? Yeah, so you could have used planetary angle there or there. Fine, yes, perfect. Is that what you guys also do? Yeah. I just wanted to show you an example with the exterior angle, just to remind you that that is still a thing. It doesn't come up often. All right, but posterior angle is perfect. We obviously could have used that as well. Remember, for posterior angles, you have to write the lines that are parallel. Okay, so if you haven't used that up until this point, if you haven't stated it anywhere, say you used a different method in 1.1.2 that didn't require parallel lines, I'm not sure if that was possible, but say you had it, then in 1.1.3, you first would have had to write that those lines are parallel because of opposite sides of palm. Okay. This triangle here. Oh, wait. That's the exterior angle. Those are the two opposite interior. So to find one of the interior angles, you can take the exterior angle minus the interior angle. Okay. Any other questions on number one, right? How are we feeling about this work? It is a bit iffy, hey, but I think practice will make it go better. All right, now number two, Josh, sorry, I'm going to chat to you about your query a bit later. This is what I did. Some of the steps you could definitely have left out, but I am just weary of doing that because I don't want to lose anyone. So let me just chat to you about what I did. There were lots of ways that you could have proved that this took off. Okay, literally like 10 different ways. So if you were able to do it and you think that it was fine, then that's fine. If you want to just come bring your book to me when you are working and just check, or if you just want me to check, that's fine. But that's what I did is I tried to prove that both pairs of the opposite angles are equal. Because I saw that we have an isosceles triangle here, so if that is 56, that's also going to be 56. Right? So we find it out. Again, I just before I even started writing anything down, I filled in what I could fill in blue. Okay, because now guys, you can't use properties of a parallelogram when they ask you to prove that it's a parallelogram. That's very important. All right, so if in any of your reasons you say like opposite sides of palm or opposite angles of palm, 0, right? They call that circular logic. You can't use what you are trying to prove in your proof. Okay, so you must be careful of those reasons. Okay, so are we fine with this? So that angle is going to be 56. Then I saw, okay, lovely, I have one pair of opposite angles that are equal. Can I now somehow prove that these two opposite angles are also equal? Because then I'm done, right? That's one way of proving that it's a palm. So I saw that I have those two angles together. And guys, actually this 62, oh, yeah, sorry, wait. So I got that this one was 56 because of opposite angles opposite equal sides, all right? Then this one is 62 also because of angles opposite equal sides. So that's also an isosceles triangle. Okay? Sorry, I skipped a few steps. Then because of these two angles here, I did angle sum and triangle to get that A is 57. Okay. So that is how I got that those two angles are equal. That pair of opposite angles are equal. All right. Angles opposite equal sides, angles sum and triangle. Okay, now I still have to prove that angle B is equal to angle B. Now guys, remember that all the angles in a quad add up to 360. That's also something that we don't use often, but it's actually quite useful, especially in this case, because I had all of the angles except for that one, which is EBF. Right, so if you're looking at the quad, we have all of the interior angles except for that one. So we can say 360 minus all of these angles, and that will give us angle EBA. Right? All 4 angles in a quad add up to 360 degrees. So that is this whole long working that I did here. Just to show you that to find angle, angle CBE, you could do 360 minus 56, minus 56, minus 68, minus that 56, minus that 62, and you'll get 62 there. So guys, this long work, you don't actually have to write down. You can just do it on the calculator, that's fine. What you do have to have is the reason angle sum and quad if you're using that. Now, if you do have, I'll give you guys now, if you do have these two angles together, angle D is 124 if you add those two. Angle B, if you now add those two together, now that we've calculated that is 62, that is also 124. Right, so there you have that both pairs of opposite angles are equal to the top. Which is how I'm done with your hand. Okay, now. I'm sorry. It is okay, let's just name it properly. So for example, this angle you could have called EBF or FBE, that's fine, but you can't call it B. Okay, so that's very important. Yes. Yes, that's fine. Yeah. So you did have to do some calculations, I think, to find angles. Guys, when you are proving that sides are parallel, maybe I should just do it on the side here just to show you the layout that you do need to use. Because that is like a converse thing that we haven't done in a while. It was supposed to do it in 8 and 9, but who knows what happened next because it was COVID. All right, so I'm just quickly going to show you if you wanted to prove that, for example, BC is parallel to AD. All right, so to prove that these two lines are parallel, you would have had to find that 56. All right, but I think we all can do that, right? It's an isosceles triangle. But if you're not allowed to write isosceles triangle as your reason, please say I'm not going to take that. You have to write angles opposite equal sides. Okay, so you would have to do that, but you would have to get your 56. Now, if I'm looking here, do we see that C shape? Right, co-interior angles form a C shape. And what do we know about co-interior angles? If they lie between parallel lines, they add up to 180. Okay, so let's say angle C plus angle D is equal to 56. So you would have to do that calculation first, right? BCD equals 56. Let me actually just copy that up there. And your reason would be, I'll move it back down just now. Your reason would be angles opposite equal sides. All right, then you would say angle C plus angle D is 56 degrees plus, now you can obviously add those two together. Are we okay with this being 124? Both of those angles were given. Okay, so you can just add those together. That's 124. So guys, you're not going to write a reason for that. Right? There's no reason for this. I'm just taking two angles that I have and I'm adding them together. I'm worried that some of you are writing co-interior angles parallel lines here. Can't do that. It's not given that they're parallel. Yes. No, you mustn't write anything. The current angle is going to come next to the copy. Okay, so guys, if you have the angles, you're trying to prove that the sides are parallel, don't write any reason next to where you're just adding them together. Okay. Now this, when we do add these two values together, we do get 180 degrees. Therefore, that's the only way for these two angles to add up to 180 degrees is if they lie between parallel lines. So now we can say, therefore, what was it? BC and AD. Therefore, BC is parallel to AD. And now your reason is very important. Right? You can't write co-interior angles BC parallel AD. You have to write co-int angles, and you can write R supplementary, or you can write equal 180. That is why we know that the lines are parallel, because the co-interior angle is added to 180. Okay, please write that down. Even if you don't copy down my method of using the angles, you are eventually going to probably have to prove that two lines are parallel, and that is how you need to do it, right? You cannot use the reason co-interior angles parallel lines anywhere in that proof, because it wasn't given that those lines are parallel. So, yes, if you have those values, yeah. You could use alternate angles, you can use corresponding angles, depending on how the diagram looks and what values you have. Those are the three things that we can use to prove that lines are parallel. Okay, co-interior angles equal 180, or alternate angles equal, that would be the reason, or corresponding angles equal, that would be the reason. Okay, are we clear, guys? Is that fine? Let me just do some quick editing here. Let me just copy this guy.
So what I had was them having 189 minus 68 minus
I'm sure that it was equal to 0.
Yeah.
You know what I'm saying?
Is that I didn't say. I,
You'll rather add that into what angle you have.
Like extend the line and add something as part of the diagram.
Mhm.
How would you to show that?
You would have to first redraw the diagram, I think, and then construct whatever you constructed. So say you lengthen this line, construct, or you can even say lengthen AB 2 point whatever, make it like a T on one side. So just you have to write down if you have that. Yes. That would be the furniture I think by itself with our line. It could be a rectangle. Yes, yeah, so you can use this to prove one pair of sides parallel, but then you have to do it for the other thing as well. Okay, you always have to prove two. Or you can do one pair of sides parallel and then that same pair of sides equal somehow, if you maybe have that information, that's another option. The other one, yeah, I was just showing you guys how to take it out. Okay, so this would just prove that BC is parallel to AB, but guys, if you just have that, it could also be like a trapezium. Right, so trapezium has one pair of opposite sides that are parallel. So you do have to then prove that these two are parallel as well, which you can do by, if you have this 56, for example, you can use co-interior angles here again, right? The exact same layout, and then you say therefore AB is parallel to CB, therefore it's a palm, both pairs opposite sides parallel. Okay. Let's look at number 3. I did this. Yeah, the question we had interviewed this in a different way. So this for number 3, they say that it is a rhombus. ABC is a rhombus with angle C. Oh, this is the question that I think Thomas was asking about. They said CBD, but on the picture it looks CBD. But it actually worked out anyway. So yeah, sorry, you might have done it differently now if you went by the wording versus the picture. Yeah, if you went with both, it was this angle from a triangle from there. Yeah, so then you would have just had the last bit. But guys, let's just, because what I did was I didn't actually notice when I was doing it myself that there was a discrepancy there, sorry. So I just worked with this 36-degree angle being given. Again, all the blue is stuff that I pulled in because they're all properties of a rhombus, right? So all the sides are equal, all 4 sides. Those 2 sides are parallel, those 2 sides are parallel, those 2 angles are equal. And do we remember that with the rhombus also the diagonals bisect the corner angles as well? Is that true? Not? Don't remember now?
No.
Yes. Sorry. It wasn't really necessary in this case, actually, because they were just asking for speed. So if you have that this triangle BCD is an isosceles triangle, right? Which it will be because all 4 sides of the rhombus are equal. So those 2 sides are equal. Isosceles triangle, so if that's 36, that is also 36. Right? Angles opposite equal sides, and then you could do angles on the triangle. Again, guys, I just write down all the stuff in blue that I filled in on my diagram. I first figured out what I was going to do, how I was going to calculate it, and then that's all that I wrote down. Okay, so in order to use the fact that this is an isosceles triangle, I first have to state that these 2 sides are equal. That's my first line. BC is equal to CB sides of rhombus. So then angle CBD was 36 degrees. Angles opposite equal sides. So then C is 180 minus that, angle from a triangle, so C was 180. Okay. Are we feeling a bit better about this work now that we're marking it? How it's supposed to be laid out? Okay. Okay, good. Okay, we are going to move on to number 4 now, which is a bit longer, although you might have been able to do it in a shorter way. Okay, number 4. Again, I just copy down the diagram and everything in blue is what I called in because they did tell us that in number 4 again is a parallelogram. Okay, so they told us that that side is 50, that means that one is also going to be 50. Right, do we agree with that? Because opposite sides of a palm are equal. That side is 80 millimeters. Now guys, the top side, the side of the palm was split up into 2 parts, but they told us that AB is equal to AE. Right? They put those lines in on the diagram. So that means that AE has to be 50 millimeters. It has to be equal to this one. So if the whole side is supposed to be 80 and that one is 50, then that has to be 50. Okay, see, I pulled all of that in before I even did any calculation. Yes?
So I want to tell you my
Hmm.
can you say the thing the first part of the there are the two lines.
Well, not isosceles. For it to be isosceles, these two sides would have to be equal. But you don't know that yet.
But if the AE is kind of
Then it's a trapezium. Yes.
then the AB would be.
No, you have to prove that first. So it would, so that would be a trapezium, yes, but it's only isosceles trapezium if you know that A, B, and C are equal. Okay, so you can't say it's an isosceles trapezium, therefore they're equal. You have to know that they're equal to say that it's an isosceles. Okay, it did actually end up being in the end, but you have to work that out.
And how did you?
So I'm not there yet, it's only just down at the bottom. All right, 4.1, let's see, what were they? Oh, and I also told it that's 110 because if it's a palm, then opposite angles are equal. So if that's given as 110, that will also be 110. Okay, but apart from that, everything else I have to calculate. So 4.1, they were asking for angles CED. Okay, now you can see that I already filled that in, that was 70 degrees. But what I did for that, guys, is I decided, okay, this is an isosceles triangle, right? This one over here. Triangle ABE is an isosceles triangle. They told us that those two sides are equal. So if we have one angle in that isosceles triangle, and we know that the other two angles must be equal, we can use this method to calculate those other two angles, right? If this angle A is 110, the other two angles will have to add up to 70. Do we agree with that? Because the three angles in the triangle must add up to 180. So if one of them is already 110, the other two must be 70. Right, angle sum and triangle. But because it's an isosceles triangle, these two angles are going to be equal. They are opposite equal sides. So you can take that 70 degrees and divide it by 2. Okay. So angle E1 and angle B1, if you wanted to say that, are both equal to 35 degrees. Yes.
Well, it's the AB.
Mm-hmm.
That AB. Or
No, you can use it. Yeah, it's fine. Okay, so are we fine with this angle being 35 degrees? You could have done it in 2 steps, guys. You could have made B1 plus E1 equal to 70 degrees, angle sum and triangle. And therefore E1 is equal to 35 degrees, angles opposite equal sides. I did it all in one calculation, but then I have to have both reasons in brackets. Okay, if you're doing multiple steps in one calculation, you must make sure that you are including all the reasons for those steps next to it. Yes? Yes, yeah, I just put it underneath each other because I couldn't put the whole thing in. Yes, so it can be in the same one. Just separated by a semicolon. So the angle sum and triangle is referring to this 180 minus 110. And then the angle of the equal side is referring to the divided by 2. Because those two angles are equal. Now guys, from there, I just use angle on a straight line actually, or angles on a straight line to get E3. Okay, because you now have 35 and 75. So that one would have to be 70. But there were different ways in which you could have done this, right? It's fine as long as you got to E3 equals 70 and you have all your reasons, right? It's very important. If you leave out even one reason, you're going to lose at least one more. Okay, 4.2 was asking for the lengths of the sides of triangle CED. Okay, now this was an interesting question. So obviously we know that, so we're looking for the length of the size of this triangle, right? We know that that's going to be 50 because it's a parallelogram. So opposite sides of a parallelogram have to be equal. Okay, so we have one length already. We know that that is going to be 30. Again, because of opposite sides of palm, if that's 80 and that's 50, that has to be 50. But we still have to find this length. So guys, you can't use Pythagoras firstly in a triangle that's not right angled. Okay, that's very important. So please, you're not allowed to use the Pythagoras. In grade 11, we are going to teach you ways of finding sides using trig in triangles that are not right angled. Okay, but you obviously didn't know that yet. So what I decided to do was I decided to calculate D because guys, if angle D is also 70, then this is an isosceles triangle. Right? If these two angles are equal, then those two sides will be equal. That was the only thing that I could think of to try and do if I don't have, right? We don't really have another way of calculating that side. Okay. So I can't remember now how exactly I got to that. C equals 110. Oh, then I used angle sum and quad, and then I used opposite angles of palm. Okay. Are we fine with this angle being 110 degrees? Because it's the opposite angle to A, right? And we know that the opposite angles of the palm must be equal. So C is 110. Then I decided, okay, B and D have to be equal to each other as well. Right? Because it is a palm. So you can fill that in if you want to. I'll use two things there just to show. Those two angles definitely have to be equal. So I decided, okay, let's use 360 minus these two because of angle sum and quad. So then I know what B and D would have to add up to. I don't know if anyone would have thought to do that. Right? Angle sum and quad, 360 minus 110 minus 110. That will give you what these two angles must add up to, right? The other two of the four. But because I know that they're equal, you could divide that by 2. Yes. Yes, I'm sure. Oh, yes, that would have been much quicker. Yes, you could have. All right, thank you for that. I'll add that now. You do have to state though that AB is parallel to CD first. Yes, perfect. Okay, I'll add that. That actually would have been faster. So guys, Christina's suggesting using just co-interior angles, which is actually quite obvious. 110 there, that's gonna have to be 70. Okay? But you have to say AB parallel to CD, opposite sides of palm. And then say, what is that? D equals 70, co-interior angle. Okay, perfect. So if you have that D is equal to 70 degrees, then it is an isosceles triangle, right? Those two angles are equal. So then that side will also be 50. So CE is equal to CD is equal to 50 millimeters. I wrote that. Sides opposite equal angles, guys. That reason is now important. Check if you got that reason correct. You now know that the two angles are equal. So now you have to say that the sides are equal. Okay, this reason is very important and it's one that people always mix up. Sides opposite equal angles. And then I said that D is 50 millimeters because of opposite sides of palm. So they gave us that 80 for that bottom side. Okay.
So where are you? I can find more straight. I had a lot of these. I did look I then back some.
Yeah.
And I looked these.
Okay.
Cool. And then in the sum, I did both those sections together. I had 360 minus 110 times.
Or over 2. Okay.
And then how would we that was?
Angle sum and quad, opposite angles of palm. So you can just list both reasons in one bracket.
It's sum of angles.
Yeah. Okay, so guys, either this or co-interior angles, right? Which is quicker. And then you And like Jonathan was saying now, where you can find the sides already, you can write them like at the start or in between, it doesn't matter. As long as all three sides are somewhere in your work. Okay. Yes. No, that's yeah, mark it down like that. Okay, any other questions on 1 to 4? Right, I didn't quite manage to finish number 5. I think I had just started filling in the sides here. Did you guys manage number 5?
Yeah, I didn't roll it.
No, I think I did say yes, 2, 1 to 5.
That 18 looks like it's OR, but it's actually in the.
Yes, oh yeah, that is important, guys. I also actually messed that up at first, which is why I had to redo. So on the picture, right, it's showing 80 millimeters there. So it looks like OR is 80. But if you again read through the whole thing, they say that PR is 80 millimeters. So actually that whole diagonal is 80, which means that, just hang on. Remember, for a rectangle, they are telling us that it's a rectangle, so I can actually also fill in here that all these angles are 90 degrees. All right, but remember, for a rectangle, the diagonals are equal and they bisect each other. So that means that all of these half diagonals are actually going to be equal to each other. So if that whole thing is 80, then these two parts are going to be 40 and those two are going to be 40. So if you're using that, you can literally just say diag of rectangle. That's really good.
Yes.
To the 20.
Yeah. It looks like
Oh,
26,
yes,
but-
yeah. Oh, there we go. Just as well I didn't do the whole thing again. Yeah, okay. Okay, let me just, so this was actually 20 degrees. Okay, what is it?
Sorry. When you get deep of that paragraph, doesn't need to be for 18.
No, no, I'm gonna take that.
And then stop, say, 351.
No, it was degrees.
Or whenever I use, when you do the calculation.
No, so for the length, you can only add that pattern. You have to add it in your calculation. Yes. Guys, I think I'm just gonna do this one and then we can mark it tomorrow. I actually want to give you some more time to practice. I worked through this on the board. I was gonna take up the rest of the hour. And I think it's better if you guys actually use time in class to work. I just want to check with you because I want to work through as well. And I just want to actually see, I do want to see what the difference between the two worksheets are. Oh, it's with X's and.
The first question.
Rude, yeah. Oh, some of these have midpoint here. Yeah. Yes, it's this one. Yeah, so you put in geometry circles, we're still doing later every year. Oh, it is a section that you put in geometry. Yeah. No, we only have to do that, I think, in term 3. Yeah, so it's just one. Guys, on the list, it might also mention midpoint theorem, but we've decided to do that only after that. We were gonna squeeze it in literally one day. But then everyone was saying like, not enough time, so can we please take it out of the exam? So if it's in that list, midpoint theorem not in the exam. Okay, you don't even know what that is, so that's just not. Yes,
Question.
no,
1, 3, 4, 5, 1.
no, you have to do it. You can do as in question 5 before question 1, but in question 5, you have to do it. Okay, guys, did I hand off worksheet 2 already? Not. Okay, I'm gonna hand off worksheet 2 now, and I'm gonna ask you, but you probably won't. Yeah, let's rather just keep working on worksheet 1 now. So you were meant to do number 5 for homework. If you didn't manage to do it like me, then you can do it now, especially if you misunderstood this instruction here. This was 18 and obviously the whole thing is going wrong. So then you can just keep working. I think let's aim to finish by, and this is on Friday, right? We're doing 18 tomorrow, please. So let's aim to finish by the end of question 9. Question 10 also looks nice. Okay, let's leave all of mine. Okay, it's fine. Let's aim to get to the end of question 9 for Friday. Yes? Yeah. Yes. Okay, so you can just have picture right there. Where I have it now. Yeah. Where any other words? No. You can do it on your own, please. No, it's fine. No, no. You have to do it. I'm gonna hand it out now. No one actually has. Yeah. You can do it on your own, and then I think I have a memo that Mrs. Glenda wrote out. Let me just check quickly. No, we're not gonna have time to do it in class. We're gonna have to get to worksheet 2 as well. So guys, we're gonna just do up until number 9 of worksheet 1, and then on Friday we're just gonna work through maybe 2 questions on worksheet 2. Unfortunately, the reality of being in an AP class is that we don't have time to do a revision in class for your exams, which is not